and now today is part 2 of our transformations journey. Today we're going to look at similarity. When we get a problem that says two shapes are similar, what can we do with it? What can we tell by that? When we get a problem that asks if two shapes are similar, then what do we do to solve that? Well, let's see. Let's look at these problems that follow. But before we do, let's look at nature. Let's look at human nature. Let's look at the way things are built. Let's look at this church right there. See anything similar about the way that that's built? Symmetrical on both sides. We have a left and right side with symmetricity. Like our faces, we have symmetrical left and right. And of course, similar shapes over here in this building with all those glass panels. Okay, as promised, a question on similarity. In this case, the question tells you, it's number 6 from the packet, it tells you that the two rectangles are similar. So what can we derive from that? Well, there is a scale factor of 4, as it says in B, which means since they're similar, which means we know we can say that this is 16, that this is going to be 32, and that's 32. Why? Because 4 times 8 is 32. 4 times 4 is 16. So that's one of the bits of information we know when we have similar shapes, that we are going to have proportionate sides. That's very key. Let's look at what else we can do once we've done that. So in this question, we're comparing the ratio of the large rectangle's perimeter to the small rectangle's perimeter. And the perimeter is found by adding the sides up, because we walk around the shape, we add them up. This is 24. When we add these up, it's 96, 16 plus 32 plus 16 plus 32. And we're going to take the large one, the perimeter of B equals 96 over the perimeter of A, 24, and that's the ratio, that's the answer, although of course we can make that into lowest terms. We can lower that as well. And when we reduce that, we're going to get 4. So the perimeters, if we compare the perimeters, it's 4 times as big as perimeter of B is 4 times as big as the perimeter of A. This part of the problem asks you to compare areas. The area of the large rectangle's area to the small rectangle's area. And when we're calculating area, we multiply the length times the width, 32 for the small rectangle, and then 16 times 32, 512 for the large rectangle. Compare them, large over small, 512 over 32. And what's interesting about this, that equals 13 when we reduce it. So what's interesting here is the perimeters. When we compared the perimeters, the big one over perimeter of A, we got 4. The dilation factor is also 4. So those were equal. In other words, when we expand something or contract it, it doesn't affect the perimeters when we compare them. It's also 4 times. But with area, it makes a huge difference. You can't just simply say that the area of the large one is 4 times the area of the small one. That comes into play later, comes into play in life as well, in all kinds of situations, which we'll get into. But for now, that's the calculation you need to make. And just note that comparing areas to perimeter, it's different. You cannot just simply say that the areas are going to compare, the number between the areas is going to compare the same way as the perimeters do. Hope that helps. Let's move on. In number 7, it gives you two shapes and then asks you if they are similar. How do you know? Well, looking at these different measurements, we can look at this side, and we notice that the small one is 15, the large one is 30, and then we take this side here, 25 over 50, and we compare these, and we notice that they're equal. They're all equal to 1 over 2. This is 1/2 of this. That means they're similar. In other words, similarity and proportionate sides work together, and then we can find a scale factor. If this were the old or original shape, the scale factor would be the new one over the old one. It would be 2. We would be expanding. If this were the original shape, we would be getting smaller, and the scale factor would be 1/2. So it really depends on how, which one is the original shape and which one is the new one. This question didn't ask that. It just said, is it similar? I'm not going to compare perimeter and area on this one because we already went over that in the last question. And you guys remember that when we expand shapes, the perimeter expands by the same amount, but the area doesn't. The area expands by a lot more than that. Okay, kids, I hope that helped. Those were problems with similarity, as you know. There's similarity everywhere, on people's faces, in people's lives, in the streets, in the jungles, and right outside of our place here, up on the roof.